All right. Today's topic is something called generics in Java. So the topic that we are going to cover has the one part is actually generics, and then we will be talking a bit about the strings, which we have already touched based on in normal programming fundamentals. So this is one of those topics that is in your syllabus, and we will go through it one by one. So what are generics? Actually, it's like it's in the core. The term generics means parameterized types. So as we know, we have like data types, right? So integers, floats, and string. So these are all data types. Just like that, we can actually define types ourselves. Say for example, we are like creating a class of our own, for example, employee, and it has some methods and attributes. So that itself becomes a type. Okay, so we can have actually an employee as a type. In one of the previous classes, we looked at type wrappers, if you can remember. So type wrapper was actually something that wrapped already available primitive types. Say for example, for int, simple int type, so that's a primitive data type, right? So there was a corresponding wrapping class which is capital INTGR. So that's integer. So for int, you had integer wrapping class. For double, you have a similar capital D OUBLE class double. So just like that, there was a corresponding type class that we had. So generics is also it's a way to pass a parameterized type. So I will when I do the examples, you will really understand this. So using generics, it is possible to create a single class, for example, that automatically works with different types of data. So we can create a single class. We are actually creating a class of something, and we can pass in different data types. We can tell, okay, this class works on integers, or this class works on strings. And the benefit it brings is it's type safety. So Java is actually a typed language. That means we can define, we always define a type of a variable, right? So when we say age, we would before specifying age, we would say it's a int age, and so that we are specifying a type. Whereas in some other languages like Python, JavaScript, we don't specify the type. We could just say, okay, it's a variable of age, var age, right? So in PHP also, we don't like specify the type. We would just say, okay, $age. So that's a variable declaration. So it doesn't have a type. Whereas in C# and Java, and there are some typed languages. So those typed languages normally use a type in front of the code, right? The code definition. So for example, if I create, so this is basically, it's a out of the box class that we have, for example. So if you do a new project, this is what you get, right? And here normally what we would do is to say if that is an integer, if we want to say, okay, we have a variable called age, we would say int age, right? So you could do something like this, right? Whereas in in PHP, you would say like $age. That's all, right? So this is how you say in PHP. In JavaScript, you would say something like this. So this is JavaScript. So if you are interested in these things also, you can just learn, like say for example, there are in YouTube videos like learn Java in 10 minutes, learn JavaScript in 15 minutes. So these are like bite-sized videos. Because you have some idea about Java, you basically can grasp any other language. The basics gonna be the same. Okay, so even if you look at C#, different languages, what the language will teach is starting with the what is a variable, and it will go through the data types and strings, and how we can create variables and assign stuff, and then it will go through the object orientation aspect of it if the language supports it. Okay, so there are some languages that supports object orientation. That means we can define stuff using classes, objects. We could use object orientation concepts like inheritance, polymorphism, encapsulation, and abstraction. So these are things that we can do, right? In JavaScript, you would say like this: age equals 32, right? So just like that in Python also, you would say age equal 32, just like that, right? So there are different languages that you can actually look into if you are interested. But for the moment, for the academic current academic sake, you actually learning Java. So Java is also an interesting and widely used language that you can ponder on. Okay, so int age 32. So this is how you give a type to a variable called age. Here actually we are going to talk about a different thing called generics, right? So here I would create a class called gen, and I would just go through some of this stuff. See, now if you look at this class, so the class name is gen. Okay, capital G E N. You can give any name here, and there should be a, it's like a diamond, less than and a greater than mark. Within that you have to give something. So that in this case we have given like T for type, right? And we are specifying, okay, this is a class that is going to focus on this type, whatever we are passing actually. So this type could be actually an integer, a double, or float, or whatever the type that you are going to define, right? So integer, double, floats, these classes are type wrappers. If you can remember, those type wrappers we can pass it in. We can pass in to this class. So those are Java defined classes. So there is user defined classes as well. Say for example, student class. If we are creating a class like student, employee, we could also pass in those classes as well. Now when I do the example, you'll get clear. So I'll just have this away for the moment, and let's focus on our code for a bit. So I'm passing in T, right? And here for T we will have we can just create an object of type T, right? So this is similar to when we say int ob. Okay, so instead of int, you are telling, okay, this is whatever the type that I'm passing in, so that type should be this object. All right, and we will specify a constructor. Constructor normally has this, right? The name of the class, and then we can pass in any parameter. Say, for example, we could say, okay, int age, right? And you can say, if we had age here, int age, so if that was a private variable, for example, you would say, I can say here p age, p for parameter, and here I would say this dot age is equal to age, right? So this is one way of passing in something to the constructor, right? I hope you are getting it. So this is like, instead of employee, see, that was an employee class, for example, and I'm passing in an age here for the employee, right? Now this is complaining because the class name is different. Okay, so, and that should be a public class, and this, because we have a gen class name, it's complaining. It should be something like this. So if you do a rename here, refactor rename file, right? Now that warning goes away. What I wanted to emphasize is on refactor. Well, I'll just go back to what it was. Rename file, gen. Here we need to have gen and pass in a type T. Here we had a type T of ob. All right, and instead of gen, we will have this. Instead of int pag, we will pass in something called something of type T of object, right? And here we would assign this dot ob, okay, to this o, right? I hope you are following me. If you have any questions, just put in the chat, and I will define a method called getOb, right? And this would return the ob value, this dot ob. All right, so here we have a constructor, here we have a method, and then I would again do another method called show type, right? So what this method will do is to show the type of this class, this class. Okay, so how I would do this is do a system out, and type of T is it should be ob dot get class dot get name, right? So basically ob is of type something, right? We don't know what type it is actually until we use this class. So it could be an integer, it could be employee, it could be double, anything. So here whatever we give pass in for this, we will get its class name, its class, and then its name, right? So we will get the class name actually. Okay, so this is the overall class we have. All right, so this is the whole class actually. So if we go to the main, you know how to create an object of this class, right? So that's basically gen, and you have to provide a type here. So instead of t, you are actually now providing a real data type. Okay, so that's integer. You would say int object, int obj is equal to new gen of type integer. Right, so this is how you instantiate or create an object of this class, gen class, right? As you can see now, instead of t, we are actually providing a type, right? And here this constructor is expecting, see, this constructor is expecting something of type t. So that's an integer that's it is expecting. We could give like this, right? So if we provide 1000, so this will pass into our constructor. So I am providing a primitive value, or just a value, and when it comes to here, it's a type, right? So what it will do is it will box it, right? Auto boxing will happen here actually, if you can remember, right? Just if you are like vague about the terminology usage, you can just revert back to auto boxing generics, auto boxing thing that we looked at last week or the week before. All right, so here int obj is our object, and you can actually show type here, right? So if you run this, see what you get is type of t is Java lang integer, right? So this is the type of the class that we passed in, right? So that's this, right? And we could actually get this value out using int obj dot get ob, right? So get ob, what does it do? If we go to the definition, get ob returns this dot ob. So whatever the value that we passed in, it will return out. Okay, so in that case we could do an s out and see. The value is, right? If we do this and run it, here the type of t is integer and the value is 1000, right? So just like this, now the real power of it comes in when we use this thing for another data type, right? So so instead of integer, you could actually pass in like a string also, strobj is equal to new gen. So what is the type it is expecting? It is expecting string, right? Because we are trying to create an object of string now. All right, similar thing. So we would say strobj.show type, right? And we would do an s out for the value. The value is strobj.getOb. Oh, you could actually, instead of getOb, you could say get value if you want. Okay, so that makes more sense. So instead of getOb, you would say get value. All right. So here we will have to pass in something, because in the constructor we are telling we are going to get something in as an input parameter. So here I would say hello Hallam City Campus. Yeah, if you run this, you would get 4 lines. There are 4 lines. So this for the first thing you have these two, and for the second one, type of T is string, the value is Hallam City Campus. See, so this is actually generics. See, you have created one class. You have created one class. Just focus on this. It's very important. You have created one class, but that class is taking a type of T. So T could be anything. T could be integer. T could be double, anything, right? And when you are using, you can use it on an integer. You can use it on a string. If you want, for example, if you had a class like employee, so this could be a real world example, and you have a private name or something like that, private string name, right? You can have a getter, and that's it. So get name, right? And you will have a constructor also. So let's create a constructor. Alt insert constructor, right? So basically, when you are creating an employee, you can get the name out. So for this, the shortcut is Alt plus insert, right? You should find these keys in your keyboard, and you can pass in gen of type employee str obj equal new employee, not employee, it should be gen of type employee, right? And you have to pass in a what it takes is it's of type employee, right? So basically you will have to do a object, or maybe you create an employee object up front equal new employee. Okay, this employee is Shiham, and you can pass this guy into this. It's not so str obj is already used, so this is like employee object, so that's emp obj. All right, and here we have two methods. One is emp show type, not emp obj dot show type, and we would have a similar thing like this. Control C, Control V. The value is employee object dot get value, right? If I just comment these out so that we don't need clutter there, so I'll run this. See, what I get is type of T is employee. The value is it's some kind of a value that is been given to this object. We can't expect the name to come out. Okay, so basically, although I have given name, we can't expect the name to come out, because in emp obj get value here in the generic class, get value just returns this object, right? Returns the object. It doesn't have a now for primitive types like integers and doubles, when you take out, that will be auto unboxed and the value will come out, right? But in our employee class, it's a class that we define. It doesn't have that capability. Okay, so because of that, what will happen is it will point to the object reference itself and try to give something. So that something is this. Okay, we don't know this value actually, maybe some memory location or something like that. but it is what it is giving is the value of that object itself. Okay, so this is about generic. So basically it's, if you go to the first slide itself, here now you should understand. I'll just switch the presentation here. Now if you read this again, you should be able to understand stuff. At its core, the term generics means parameterized types. Okay, so parameterized types like integer, I have shown an example, parameterized type like a string, parameterized type like employee. Okay, and using generics, it is possible to create a single class, which is our gen class, right, that automatically works with different types of data. Different types of data. I showed you how it works with integers, how it works with strings, and how it works with employee. So different types of data, right? And it improves type safety. Type safety means it is strongly typed. We can actually pass in an employee type or integer type, right? So because of that, we could, have some safety nets about the data types. So that was the demo. So we have done this. Okay, so for the moment that what we looked at is actually, for the gen class we passed in a capital INTGR. So it's an integer class wrapper, right? That is what we used. Actually, you can't use this thing, the primitive version of it. Okay, so that's a rule that you have to understand. You could get some MCQ questions regarding this. Okay, so they might test this knowledge specifically. So you can't pass in the primitive version of the data type to a generic class. Okay, and the second one is generic types differ based on their type argument. So that we have looked at already, right? So type argument means this one, whatever that comes in this less than greater than mark, which is integer here, which is string here. So these are the type arguments. So basically whatever, based on whatever we pass into this, the behavior is going to change. And here is a good example where you have an integer generic, integer class of gen, and here you have a string class of gen. Okay, here we are creating the object. Okay, and assign it to I. We are creating the string version of it, assign it to str. And since we could think like, okay, it's the same class, right, gen and gen, can we like assign one of the string classes to the integer class? If you try to do that, I equals, or str is assigned to I, it would say incompatible types, because it's the type is different, right? This is an integer version of it, this is a string version of it, right? So to elaborate that point a bit again, I would just get rid of all of this, and I just wanted to show this only, right? So I have an int age of 32, right? Some int, what we can use, int number of legs 2, right? So I would say s out age now is 32, which is age, right? So at a different point, I could say age is equal to legs, for example, because this and this type are same, right? And if I now print this thing again, okay, so I hope you are following me. Age is 32. Now at this point, I'm basically changing the age value, right? Age is now equal to legs, which is 2. And if I print this out again, I should get 2 here, 32 here. Okay, so oh, this is printf actually. ln, I'll do an ln here. Print ln. All right. See, now this is possible when we have like same data type for non-generic stuff, right? So when it comes to generics, you can't do that, right? I don't want to type all this stuff again. So here in terms of generics, this is sorry, this one is what we are looking at. So gen integer I, gen strings str. So integer version of it and string version of it, you can't assign between it, right? Because these types are different. All right. And up to now, what we looked at is on passing in only one type, right? So the gen had only one, gen class had only one parameter type. So in this case, we have like 2. If you want, you can have 3, 4, multiple, right? So here it is basically telling public class 2gen, the name of the class is 2gen, and it is taking 2 types of parameters. So type T and type V. Okay. So this same as the gen class, right? Here, but we have 2 types here. So in this constructor, whatever we take in, we assign it to these OB1 and OB2. That is what's happening here, right? And the usage of it, for example, in our main method, we would use this class as this 2gen integer comma string, right? So that means for instead of T, what is coming in is integer. For V, what is coming in is string, right? And we will have to provide something, some object name, and we are instantiating this and providing 2 values, right? So the first value should be of type T, which is integer, okay, and the second one is type string, okay. So that's what we are passing here. So this class actually can be used not only for integer and string, you can use it for string and string, you can use it for integer, you can use it for double string, right? Basically any data type. So you can pass in any data type here, any data type there, but the rule is you can't pass in primitive values, primitive data types, right? So say for example, simple int, it's not possible, right? I hope you're getting it. And actually that's about generics. Any questions? Any questions? You can ask.